Everyone say hi, period 4.
Hi, period 4.
All right, period 4, this is for you. You guys are special because you guys were on a little field trip. Hope you have fun at Cal State Fullerton. All right, so the handout, the graph paper side is the front side. The back side is those 4 graphs that you see. So turn it around. Make sure you got 4 graphs that are already created for you. That's the back side. Go back to the front side. Go back to the front side. So we've got 6 questions, 723 to 728. We're going to do a lot of back and forth today. So I'm going to make you do stuff, then we're going to call you back. We're going to talk. We're going to make you go back and work, back and forth. Okay. First, we're going to start with some notes, though. So go all the way to the bottom of your lesson. And you're going to see this math notes box. Go down there. Okay. Next, what I want you to do is get these 6 graphs in your screen. You can zoom in. I'm talking to you guys. Do it right now. Like, kids in my classroom, do it. Kids watching the video are going to do the same thing. They're just going to do it a couple hours later than you. So fit it on one screen. You can zoom in if you need to. Take a screenshot. Take a screenshot. Okay. I want you to save this because this is going to be an important form of notes for you. There's no point in rewriting all of it, but you are going to write some of this down on that graph paper in front of you. So let's start out with some quick notes. When we describe association, when we talk about a scatter plot, we're going to use words and language that you're not used to. This is where you're going to find all that language, but I'm going to take out the key points of information. So right here where it says positive association, let's couch this under the category association. Okay? That's the word. Association is another word for relationship. Write that down. Oops. Right, so association is another word for relationship. In other words, how are the two things related? Well, if it looks like this, kind of like yesterday, as x increases, y increases, that's positive. So write down the word positive. That's one way you can describe association. The next word we're going to write down is negative. Things are decreasing, right? As x increases, y decreases. So negative association is the next word you're going to write down. Lastly, I want you to actually copy this diagram real quick. The no association. Go ahead and give yourself a scatter plot that's actually randomly scattered like this. Draw a bunch of dots everywhere. And let's also write down the phrase no association. So copy this down and write down that phrase. No association means there's no relationship, there's no pattern. And I described to you yesterday why that made sense. There's no way I'm going to draw a line of best fit in here, and that's going to make sense. On these first 2, I could draw a line of best fit, and that makes sense. It follows the pattern. I could draw a line of best fit, makes sense, follows the pattern. I can't do that over here because there's no line to draw. I can't figure out if this thing's going down, if it's going up, if it's going across. I don't know. Okay? So that's what you're doing. Any questions about association? Yeah.
What would it be called if it was like a straight line?
Like a horizontal line? It would also be called no association. Good question, good question. All right, let's go to the bottom half now. This is what we call form. So write down the word form. Form is the way it looks. You're judging its looks. You guys judge each other's looks all the time. Like for a rate, like for a comment, like for a TBH, all that stuff. Yeah, I know what you guys do. You guys are going to look back, by the way, in like 10, 15 years and be like, wow, that was kind of weird. But hey, you guys have your childhood, I have mine. We all look back and we say, yeah, that was kind of weird. In any case, here we go. What does this first one look like? Well, it looks like a line. So then we call it linear. Write down the word linear. So linear is one way. Josh, write it down. Well, linear is one way you can describe the way it looks, its form. The next word is nonlinear. Write that down. Why do we call it nonlinear? Because if I look at this second graph right here, it looks like it's curving. That's the form. It looks that way. So we call it nonlinear. Lastly, we also have to talk about clusters. Write down the word clusters. Clusters is a phrase for, are there groupings of points? In other words, like this group up here, that's one cluster. This group right here, that's one cluster. How many clusters does this graph have? So you would say linear with 2 clusters. Am I making sense? Are there clusters here?
No.
So we just say linear, no clusters. We would say nonlinear, no clusters. Linear with 2 clusters, because you've got a cluster here and a cluster here. So cluster, that word cluster, is part of the description of your form. You got to include it, or you say there are, how many, or no, there are none. Any questions about descriptions? Okay, we're going to become experts of this after today. All right, let's move on. Let's go back to our very first question now, 23. In 23, you guys are going to practice some sentences here. We've got to figure out as a group what's going on between some relationships. So let's read 23. The students in Mr. Carl's science class have been experimenting with different factors that they think may affect how tall a plant will grow. Each team planted seeds. That means they planted more than one, not just one, in several pots. Okay? With your team, read the questions that the students investigated. Write a team prediction for the results. You're going to make a hypothesis, just like in science. What do you think is going to happen? Okay? Assume that all of the variables, this sentence right here, guys, that just means don't be too crazy about it. Don't get too technical. Let's just think about the situation. Write your hypothesis so that it indicates a directional relationship. Are things going to increase? Are they going to decrease? Or are they going to remain the same? That's what we mean by directional, Keller. Pay attention. So I will do the first one with you. Does the amount of fertilizer affect the plant height? What is fertilizer? Let's just talk about that real quick. You don't have to tell me actually like literally what it is, but what is its purpose? What is fertilizer's purpose? Yeah, Cameron.
Make plants grow faster and taller.
Right, it's more food, it's more nutrients. It's like giving plants more than just water and sunlight. Okay? So it's like giving them like vitamins, plant vitamins. So, what do we think? If we give plants more vitamins, do we expect the plant to grow a little taller? Right, that's just with humans too, same thing. So how are we going to write this as a hypothesis that indicates directional relationship? Here we go. All right, we're going to say yes first. Does the amount of fertilizer affect? Yes, it does. Here's how we write it. Yes, the more fertilizer, right? The more fertilizer. Okay, the more fertilizer, what do we say? Bigger or smaller the height? Bigger. The bigger or the higher. We need direction. Notice that we're using words within the question. Fertilizer, fertilizer, height, height. Here are the directional components. I will highlight the directional, meaning more, less, bigger, greater, smaller, right? That's what we need. So you guys are going to go through these 4 and do the same thing with your group together. On the video, we're pausing. You guys do this by yourself. Good luck. Bye. All right, kids on the video, we're back. Okay, rest of the class. What do we think? B, how deep the seed is planted in each pot affects the plant height. Keller.
Yes, the deeper they are, the lower the height.
Right, so the deeper the plant is, the seed is planted, the less tall it will be. Right, it's got to break through the soil. If you plant it 10 feet deep, it's got to travel 10 feet up. It might be 10 feet tall, but we won't know because it's covered in dirt, right? So the deeper the plant is, the seed is planted, the shorter the plant height, like that. C, the number of seeds in each plant or each pot affect the plant height. What do we think for C? The number of seeds. Yeah, Cal.
No, the more the seeds, the more plants.
So you say, wait, but we're talking about height.
Oh,
So you're talking about the number of plants. We're saying, so the number of seeds in each pot. So I've got a pot. Let's say it's as big as this tissue box, right? And I put like 30 seeds in here. Or some next kid puts like 2 seeds in here. Do you think plant height would change? No? Okay, so Cal says no. I'm not going to say yes or no, but Cal says no, it's not going to change. D, does the size of the pot affect the plant height? In other words, I take 1 seed and I plant it in this tissue box, or I take 1 seed and I plant it in this cup. What do we think, Kelly?
Yes, because the roots need room to grow, so then it will stop it from growing.
All right, so Keller's getting pretty deep, literally deep, right? So roots need to grow, more roots or deeper roots, taller plant. Okay, I like that logic. E, does the number of hours of sunlight per day affect the plant height? I just said most plants just need water and sun. So you get more sun. What should we expect for the height to be?
Yes.
Height to be yes?
Lower.
Higher. You're going to be taller. Good. Okay, so let's round this up. Let's keep going. 24. Here we go. After 3 weeks, the teams measured the heights of their plants and recorded the data. The team 1 data and the question team 1 investigated are below. So here's the team question. Does the amount of fertilizer affect the plant height? Here's their data. This is for 6 plants. They did 6 plants. So each plant they gave a different amount of fertilizer and they recorded the heights of each of those 6 plants. Here's what we're doing, ladies and gentlemen. Let's make a nice graph where you have your axes labeled. What do we mean? We need your titles. That's what it means. Don't just give me blank x-axes and y-axes. Okay? Put some titles there. Also, do you have intervals? Let me give you a tip for today. Let's use 5s. Okay? 5s is going to be perfect. So if I go 5 on the x-axis, 5, 10, 15. 5 on the y-axis, 5, 10, 15. You're going to be good. We need a title for the entire graph. The bold letters here should be perfect for that. Go ahead and do that. Take some time. It'll probably take about 2-3 minutes. Kids watching the video, make it happen. All right, here's what you should have. Something close to this. Doesn't mean it's identical. Just means it's pretty close. So there's your X. That's going to be your fertilizer. This is going to be your height. I told you to use 5s. I'm just going to draw a quick sketch without any intervals just to show you what you should have. You should have some data points that start right about here, correct? Right about there. About, right? And then it continues to go in an increasing fashion like that. I know I drew more than 6 points, but that's pretty much what you do. Agree or disagree?
Agreed.
Okay, good. So something like that, okay? That's where we should be. I'm just drawing a quick sketch. You guys make it more accurate, please. All right, so we're going to move on. Let's do the next question, which you're going to thank me for. It says, problem 25, your teacher will assign your team one of the remaining sets of data. Normally what we were supposed to do is one group would take team 2, one would take team 3, yada, 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 and you guys would have to graph another set of data points. I didn't do that because we don't have enough time. Turn your paper over to the 4 graphs. Each of these teams, teams 2 through 5, are represented in those 4 graphs. You are welcome. I should hear a.
Thank you.
That was so sincere. Thank you.
Thank you.
Just kidding. Like that. All right. So, team 2, team 3, 4, and 5, each of these is already on there. So, in other words, you don't have to graph it on your own. You got it all because you're going to need them all. Okay, you're going to need them all. So, question 25, done. Yay. Let's move on. 26, rubber meets the road. We are going to do 26 together because you're going to do this problem 5 times. Okay? That means we're going to do those graphs that the one you created for team 1 and team 2, 3, 4, and 5, you're going to repeat 26, okay, for all 5 graphs. So go back to the front side where your graph is. Go back to the front side. What we're going to do is next to each graph, we're going to describe it using the language that we are going to learn for today. So all the way down, all the way up. So first, we need to describe it using a sentence frame. So you're going to either do this or do this. That means you're not doing both. The first one is if you have any increase or decrease. So if there is a pattern, you're using the first one. The second one, if there is no pattern, then you use the second sentence. Here's how we do it. This is a general description. You are not using letters. As X gets larger, then Y gets what's happening, right? You tell me. So X is going to be your X-axis title. Y will be your Y-axis title. And then you're going to tell me larger, smaller, increase, decrease. You're going to decide that. So let's do this for graph 1. Graph 1 looks like this. Let's go back here. Where is it? Here's graph 1, right? So, does it look like there's a pattern here? Yeah. Okay, so it's going to be the first sentence. So as X, no, I'm sorry, not X. As amount of fertilizer, write this down, as amount of fertilizer, and this was that line you're supposed to fill in, that was your X, as amount of fertilizer gets larger, right? So as we are making plants eat more food, what's happening to the heights of these plants?
Getting taller.
They're getting taller. So the y, the height, and that's our y, right? That's the y. The height gets larger or gets bigger or grows more. You can insert the word, but you have to include the direction. So I'm going to say it gets larger or bigger. Okay? And so those lines that I just drew are the fill in the blank portions that you have to do. Make sense? Okay? Let's go to the next question. The next question then after part A is B. What's the direction? So go back to that first graph. Look at the graph that you have. Looks something like this. Would you say that's a positive, a negative, or no association? So write down positive association. You're going to write the phrase positive association next to your graph. You can write it either next to that sentence that we wrote or underneath. It's fine with me. Let's talk about form. What form is it in? Is it going to be linear, nonlinear, linear, or nonlinear? Take a look at your graph. What would you say?
Linear.
That's a linear, right? So we're going to say linear. Now we got to talk about clusters, okay? So are there clusters or no clusters?
No clusters.
So linear with no clusters is the other phrase that you would write. Linear with no clusters. And we're talking about this one right here, right? This is the original. That's the one you did. And lastly, we didn't talk about this, but it's not a hard concept. Let's read this together. An outlier, please write this down. An outlier is a piece of data that does not seem to fit. In other words, it doesn't belong with the data. So let's go back to this mini sketch of what you have. Is there an outlier here that just doesn't belong in this pattern? Meaning it's obvious, like, hey, what the heck is that point doing there? Is there a point like that on this graph? No. It would look something like this. Like, it would be super, super obvious. Or it could be like all the way up here, right? That would be an outlier. So we're going to say, does this have any outliers? So you're going to say no outliers. Write that down. So to help you describe that part, no outliers. You're now going to repeat this process for Team 2, Team 3, Team 4, and Team 5. Basically the entire backside. Make sense? Okay? All right. Kids on the video, make it happen. And the rest of you, make it happen. All right. Even if you're not done with number 26, 26 is the same repetitive thing for those 4 graphs. So you know what to do. Everyone in class, let's move on to 27. Okay? 27 is an important question because this is kind of the mathematics part. So far, all we did was create a scatter plot, and then we described stuff. So describing is always like interpreting or analyzing. Now we're back to the math part. We're going to figure out some numbers. Okay? So find your team 1 data. Okay, so that go back to the front page. Okay, the one with your team 1 scatter plot, and draw a straight line that models the trend of the data. In other words, draw a line of best fit. Let me show you what it should look like. So here is the one that you guys I'm simulating. It should look something like this. That's horrible. One more time. One more time. One more time. That might be a bit better right there. Okay, so go ahead and do that on yours. Use a ruler. Okay, make it straight. Make it in between as many points as possible, but it's got to follow the trend, the format. Right? We said this is positive. We said it's linear, so it's better be straight. Now, question B says, now use your line of best fit. So we're going to take this line of best fit to predict the height. That means we don't know what the height is when the plant uses 12 milliliters of fertilizer. All right? Here's your fertilizer. Go find 12. Your fertilizer's down here. Go find 12, wherever 12 is. Once you find 12, go straight up to your graph, to your line, and figure out what that y-coordinate is. If you don't know what it is, move over to the left to figure out what y-coordinate that is, and write that down as centimeters. Okay? Because the height is in centimeters. So at 12 milliliters of fertilizer, what is the height? How tall is your plant expected or predicted to be? Okay. Now, everyone's answers might be a little bit different. So right now, go ahead and compare your answer for B at your table. You should be within 2 or 3 centimeters of each other. Go. Talk about it. About 2 to 3 centimeters off, that's fine. All right, let's come back. Question C. What is the y-intercept? The y-intercept is where your graph crosses the y-axis. So put a big dot here, ladies and gentlemen, right on the y-intercept. Go ahead and record that number, whatever it is. You're going to have to guesstimate if it's not a perfect point. Right? So if it's in between 5, 10, or 15, you're going to have to guesstimate. I'm going to take some numbers here because I want you guys to compare each other's y-intercepts. Cal, what'd you get? Y-intercept. About 9. So Cal got a 9. Anybody else get something different but close? Dylan? 7, that's about right too. What else? Anybody get 11?
I got
10, okay. Anybody get 11? Michaela got, what'd you get? 11. Anybody get 12? I would say 12 is probably the highest. Anybody get something around 5? Probably not. So, these are within 2. If I say 9's in the middle, plus 2, 11, right? Minus 2, 7. So we're all good. We're all good. Now, we just found out what the y-intercept is. Let's label it with units. What is this? 7 what? 9 what? 10 what? 11 what? These are all in centimeters, right? So write down whatever your y-intercept is with the unit attached to it. Now, here's the most important part. Okay? I'm going to take some time here. Interpret the y-intercept in the situation. We just said that it's either 7, 9, 10, or 11 centimeters. But what does that mean? In other words, comparing the two, the fertilizer and the height, what does it mean? What does that 7, that 9, that 10, and that 11, what does it mean? Okay? Think about it for about 5 seconds. 4, 3, 2. All right, talk with your group. What does that mean? Interpret the number. What does it mean? Talk about it in relation to fertilizer and height. Go, discuss. Go, make it happen. Go, go. All right, let's interpret this. How much fertilizer is given on the y-intercept? Or how much fertilizer is used? What was that number? How much fertilizer is used on the y-intercept? 0 fertilizer. So, let's interpret. When, write this down, when no or 0 fertilizer, what's going on with my writing here? Fertilizer is given to the plant or the seed. Let's call it the seed, the plant. The expected or the predicted height what is the predicted height? Whatever you have, right? Write it down. The predicted height is blank centimeters. So that what we're saying is, hey, if we're not giving any fertilizer, it's going to be around this tall. But we do give it some more fertilizer, we're going to predict it to be around this tall. That's what interpreting the y-intercept means. Okay? Keep going. Actually, let's pack it up because we got a minute left. So pack it up. I did say we're going to take the entire period. All you have left is the learning log. You finish that at home. Kids at home, finish that up. Bring it back tomorrow. Thanks for watching. Bye.